Well, I'd like to start off the afternoon by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and even in homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and that's essentially where students are going to be required to design and build a series of original prototypes, all based upon their own research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted expert and STEM educator, Tom White. So today we're going to start off where so many technology-focused presentations for education do start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the school, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, well, when you hear someone say this, what they're really talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to be going into. Now, in the employment market that once greeted our grandparents or our parents, good work ethic, a strong back, and basically being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly, so to speak. But now, students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and all sorts of rapid advances in all aspects of technology. So in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade or so has been on developing STEM skills. Every new advantage we enjoy, such as the tablets and smartphones we all use daily, or AI, or any of these things, was all created because of individuals who helped to make those advances. Countries all over the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. So here in the United States, we also need to prepare the next generation of students with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to become part of the next wave of advancements that we're going to rely on to stay competitive on the world stage, and of course, to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is pretty much in agreement about the importance of STEM and technology-focused programs, we're going to basically move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, or AOI, and computer science. IoT, what am I saying, AOI? The Internet of Things and IoT and computer science. And all extremely important subject areas for students to be exposed to, and of course, all skill sets that are highly prized in today's technology-focused market. But just how highly prized are we talking about? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So pretty prized. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they, of course, need to start developing the habits and the mindset and the career focus as early on as possible, in high school at least, if not even in middle school. Now, the dilemma for educators, whether you're in the classroom or even in the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts to take a few tests and then to promptly flush them away. No, to really help students to be successful and to encourage them to consider pursuing further education in subject areas like this, educators need to be able to present the material in a way that makes it relevant, which of course means answering the eternal student question, which is, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than textbooks and lectures and video presentations do, something that has visible real-world applications and where the students can get involved in doing things hands-on. And it's with this dilemma in mind that we created the Studica Mechatronics programs. Now, these two special sets, one of which was designed as an introduction to the world of mechatronics, and the other of which is intended to be essentially a standalone class dedicated to the subject of mechatronics, each of these were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that, again, is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards in place. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which, as I mentioned before, was created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. The curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. And it's also designed for offering a project-based learning program. And this, of course, means that solving the problems that arise in each unit will require the students to be actively involved in the research phases, the design phases, the trial and error experimentation and activities, and also the building of actual working prototypes that will provide the required answers to the questions. And students aren't going to be asked to do this alone. They're going to be asked to work in small groups or teams of 4 students per team. And this is basically to help develop the soft skills that students also need as much as they need STEM skills. And by this, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, actually, I have to correct that, it's now free programming software. With the exception of that, each set includes all of the physical building materials the group is going to need to address all of the design projects presented throughout the course of the curriculum. Now, the curriculum itself is designed to enable teachers of all backgrounds, and that's even teachers from non-science or technology-focused disciplines. It's basically designed to help them to have all the information they need at hand, properly prepare them for conducting the activities, and to help increase their own comfort in presenting this material to the students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system that they're going to use to address the projects presented in each unit. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are teams of 4 students per team to create a solution. The project units each contain embedded academics. And at the end of each unit, the students again will be required to make a formal presentation of the prototype they have created to address this particular unit's real-world style scenario. And also asking them to explain the reasoning behind why they constructed or, created this particular prototype to answer their questions. There's also a technical literacy task driven by each of these projects. Now, as they work to address each project, students will acquire the knowledge they need through inquiry and exploratory research. Science, math, and tech-based skills are acquired through the carefully designed enabling activities. Now, again, as required by each project, students will be asked to create original prototypes and any programming required, any kind of program that's required to, move the models, to control the models that are going to be done. And that's all up to the students. And also they have to maintain detailed documentation during the entire process. Now, as I've mentioned a few times in the presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. And of course, you see Tom on the screen now. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom is one of the people pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. And currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted academic standards currently in place in the United States. And these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K to 12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they've been presented with might come across as too abstract to ever be useful in their lives. But with this project-based approach, students get to see firsthand why these things are necessary and where they're useful. The concept of working in the small groups to solve the project problems that are presented also helps students to develop the high demand soft skills that employers look for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving, to name a few more. Now, in this project-based format, all of the subject matter is integrated. And by that, I mean the math is integrated with the reading, the writing, and so on, which is ideal for STEM education. And because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research phases, the testing, and the group give and take, to provide just a couple of examples. Because of this, it allows for a much deeper exploration of problems than, let's say, traditional teaching methods might allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in the types of prototypes and solutions being offered by each group. Now, this could, of course, be because of differences in creativity or differences in research and approaches taken by each group. But in any case, students can also see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they're going to need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Again, research that's utilized in the design phases, the prototyping, testing, and evaluation phases, and also the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough material for teams of 4 students. The team approach, as stated before, helps to promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, which I touched on before, is included inside each box. Access to the free curriculum download is included with the purchase of each set, and also included are all of the building materials which students will use in the creation of each of their prototypes. Now, the materials that are going to be used are from the unique Fischertechnik building system, and among the components included in each set are 2 robotic controllers and 2 power supplies. Now, of course, some people may not be familiar with Fischertechnik, so please just allow me to provide you with a little bit of background. Fischertechnik is a flexible and innovative construction system. Now, unlike a lot of other popular construction sets that you'll encounter where you essentially just stack things, Fischertechnik was created with more of an engineering mindset. The core building block that you see on the screen right now in the Fischertechnik system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the system itself offers a wide selection of very specific parts for technological models like you're going to be encountering here. And this is going to be a lot of variations on gears, girders, sensors, and much more like this. And because of this, it allows technical builders to address equally specific design needs. Fischertechnik was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was also the inventor of synchronized flash photography, and that was back in 1949. And he is also known as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt or something of that nature to help anchor heavy objects to walls. We pretty much all use them. Now, his company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices like this that are used in building construction. And they also produce components used in the automobile manufacturing process, as well as providing consulting services related to automated processes. Now, with all that said, let's begin looking at the specifics of each of these two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you can refer to this one as SIMP. Now, the set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. Now, the curriculum itself contains enough activity material to fill approximately 45 academic hours. Now, with this in mind, we recommend the program set for insertion into regular related class activities for use as a short class unto itself, or for after-school program use, or of course, homeschool use. The curriculum created for the set is standards focused, again using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again for addressing these same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fischertechnik building components, and this is going to be everything again from gears, wheels, axles, blocks, sensors, and much more, as well as 2 robotic controllers and 2 power supplies. Only the required robotic control software, which I will discuss later, needs to be added in. And again, that used to be affordable, and now it's free. Now, the curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas as they come up during the course of the curriculum. This includes things such as sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch or the digital phototransistor, working with open loop and closed loop programming, as well as digital branching, working with analog sensors such as the photocell LDR, working with analog branching, working with more sensors such as the NTC resistor or the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered in the second set. The second set is the Studica Teaching Applications of Mechatronics Program. And in this case, if you wanted the acronym, this would be STAMP. The set itself is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to a free downloadable 400-plus page curriculum document, this time entitled Mechatronic Applications, also by Tom White. The activity materials in this curriculum document, when used in conjunction with the components of this set, is designed to fill approximately 180 academic hours. So we're looking at essentially 4 times the amount of academic hours being covered as by the previous set. Now, as such, this set can be seen as a more expansive version of the material touched upon in the previous set, and it is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent of every week for a full academic year. So you need to be able to have that time to really go through this set properly. Now, again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or again, for addressing similar grade levels in a homeschool environment. The materials in this set consist of a selection of over 1,200 Fischertechnik building components. And again, this is going to include an array of gears, blocks, sensors, axles, and much more. And again, you get 2 robotic controllers and 2 power supplies. And then you'll just need to get the free software, which again, I'll tell you about after. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as with the previously discussed set. And this includes units on sketching and documentation, simple machines, mechanical systems, basic electricity, along with project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And this set includes sections on sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital phototransistor, working with closed loop programming, working with digital branching, logic gates, and combinational logic, working with edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, or the potentiometer, and working with data. Now that we've had a look at how each set differs and the specific subject matter covered by each, let's backtrack now and look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each project unit. And as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is again designed to be turnkey. And what I mean by that is that each unit is designed to clearly spell out everything that's going to be addressed. And it's designed to provide the tutorials and other information as the topics arise. And this is done specifically to enable teachers from all sorts of backgrounds, including those teachers who come from a non-science or non-tech-based background, to enable them to quickly become comfortable with delivering the material simply by reviewing each section before they present it in class. Each unit presented in the curriculum for each of these sets includes the following sections: an introduction, the purpose of the project, a description of the concepts, an outline of the material, an overview of the standards, assessment rubrics, the essential question being asked, the student scenario, the real world style problem that we talked about, daily plan, vocabulary words and terms, and other resources. Now we're going to look at each of these a little bit closer. When we get to the introduction or the purpose of the project, it's essentially an introductory section that, just like you would likely gather from the name, it provides a brief description of the topic that's going to be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they're learning the material and why it's important for them to know. The next section focuses on the main concepts to be addressed in this particular unit. And these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that's going to be essential for them to understand and utilize, not only today, but also to draw upon as they move forward in STEM fields of study, and if they choose to pursue it further, hopefully in STEM-related careers. Following this, we encounter the outline. Now, in the outline section, we drill down more specifically to what will be addressed in this particular unit. Now, as the example that I'm sharing on the screen right now is taken from the unit that addresses aspects of programming, you're going to see that, of course, we touch upon areas such as the methods for writing programs, which could be flow charts, word problems, etc., program characteristics, things again like open or closed loop, branching, for example, would it be digital or analog or subprograms, and so on. The next section of each of these project units will focus on the specific academic standards which will be addressed in that particular unit. Again, as you'll see, this includes the college and career readiness math standards, the reading standards for literacy in history and social studies, the writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include both rubrics for the specific project being covered, along with general rubrics for literacy tasks that, of course, would apply to all the units. Next, we find the essential question, and this can be thought of as kind of the big picture question that's going to be focused on in each of the smaller individual activities that the students are going to encounter. And of course, all of the aspects of the larger project at hand, which students are going to be asked to complete in this section. Then we have the student scenario, and this is where the specifics of the project to be addressed are finally spelled out. Now, as I mentioned, this is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved by the creation of some sort of a device, a machine, a mechanism, something needs to be created here. Now, as I mentioned before, students aren't going to be asked to do this on their own. They, again, must work together in small teams to craft the answer to the challenge they're presented with. Now, solving this problem is going to require each team of students to design a unique and original answer, which once again usually comes in the form of a working prototype, along with whatever programming may be required. So just to provide an example, if you look closely at the student scenario that I'm sharing on the screen right now, you will see that the project in this unit has each group of students taking on the role of a design team employee. And in this case, the employees in the design team work for a firm that manufactures garage door openers. Now, in this case, students are being required to design a specific type of control system for a new line of garage doors. And the manufacturer's requirements are all spelled out in this little section, such as in this case, that they're going to need to include limit switches. They're going to need to meet certain safety codes that require a method for sensing if anything is in the way of a closing door. And also they're going to have to incorporate an automatic light into it. So again, each team of students are going to be tasked with creating both a unique and original prototype. And of course, in this case, it's going to be a garage door opening system that meets these requirements, as well as the programming used to control the prototype. Now, as the students move through the challenge being put forth in this scenario, each student team is going to be required to document the entire process in both a design notebook and also in a digital engineering journal. And this means, of course, noting all of the research, any trial and error experiments that they conduct, to keep copies of all design sketches and any revisions they make, and so on. Now, at the end of each project unit, as I touched on before, each team of students is going to be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and the programming in action, and much as they would be required to do if they were actually employed by someone in this field and they had to create such an answer. Now, when we move on to the next section, we encounter the daily plan. And this is the section that spells out clearly, both for students and for teachers, what's going to be expected of the students each day, how the teacher is going to conduct that day's classroom activities, and what specific subject matter is going to be covered. Now, for example, if you look at that, you'll see that some days may involve discussions, other days may involve more research, or even building small projects that are going to help provide building blocks that students are going to draw on as they complete the larger project being described in the student scenario. But in short, you can think of the daily plan as a roadmap designed to keep everyone, students and teachers, on the same pathway. Now, you're also going to see that along the way that as different aspects are addressed in each day's activities, such as, for example, what's going to be required in a design notebook, or how do you use the control software, how do you work with the controller, with flowcharts, or what have you. As these things come up, there are links to sections that provides further instructions and information on each of these areas. So again, there's no reason for anyone not to know how to deal with that. You have a link you can go to, and it'll provide the answers. Now, at the completion of each unit, after the last day of the daily plan, there's a section containing vocabulary, and this can be thought of as important words and terminology introduced during the project unit, as well as a selection of useful resource material. Now, the resources can contain a mix of different types of material, things like carefully vetted websites, video links, or even PDF documents, PowerPoints, what have you. It's all going to depend on a particular unit. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fischertechnik building system. Now, this will include information on how the various parts fit together using the pin and groove assembly method, how to identify the different types of parts from the various types of girders and blocks, the different types of axles, gears, rivets, and so on. And students are also going to get to build a very basic sample model just to help familiarize them with the system before they move on to the larger projects in each unit. And as learning about and maintaining proper documentation is one of the areas that's stressed in the course of the curriculum for these sets, there is a section which details just what defines each type of documentation being required and what is, what types of things students are going to have to enter in each. And as the process of conducting these types of more open project-based class activities might also be new to a lot of teachers, there's also a section in the curriculum that discusses specifically project-based STEM education and its benefits. And that essentially completes an overview of these two sets. So with that in mind, let's quickly review the contents and purpose of each set, but this time we're going to offer the pricing. First, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Again, it includes the highly detailed 242-page curriculum document entitled Mechatronic Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material, again, to fill 45 academic hours. It's designed for those educators who wish to offer a shorter class on this material, who would use it for after-school activities or programs, and of course, for homeschool use. The teaching material is designed for use again in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics at these particular grade levels. The physical materials in each set include a selection of over 700 components, including blocks, gears, sensors, and more, all taken from the Fischertechnik building system, along with 2 robotic control units and power supplies. These are the materials that, again, are going to be used to construct the various mechanical prototypes that are addressed in each project unit of the curriculum. And there is software required, but again, as I touched on, it's free, and we'll get on that in a second here. Again, each set is designed for use by teams of 4 students, with pricing starting at just $699 for a single set. So $699 for a single set, and discount classroom pricing for groups of 20 students and up is available by quote upon request. For the second set, which again is the Studica Teaching Applications Mechatronics Program set, once again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, and it's all based around a highly detailed 400-plus page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, because this is much longer than the previous set, it's designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent. If you can offer a whatever, a roughly 4.5 hour class once a week on it, if that's how you choose to approach it. Essentially, you need to do that for a full academic year when you're using the set. The set is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these particular grade levels. Again, each set contains an assortment of over 1,200 components taken from the Fischertechnik building system. Again, this will be blocks, girders, beams, sensors, axles, and much more, as well as 2 robotic control units and 2 power supplies. Once again, each set is designed for use by teams of 4 students, with pricing for a single set starting at just $799 per set. And of course, discount classroom pricing for 20 students or more is available by quote upon request. Now, as I mentioned before that software was required, let me address that as well. The software in question is called Fischertechnik RoboPro software, and it's essentially graphic programming software. And because of this, it means that it's really based around a flowchart style design where you use various icons which students arrange and link to create the programs being used for each model. It's really ideal for teaching the fundamentals of programming to users of all levels. Now, as I mentioned before, it's absolutely free and it can be downloaded directly from the Fischertechnik manufacturer's website, which is fischertechnik.de. And of course, when you do purchase a set from us, we can also provide information on that directly to you at that time. So no worries there. And I see a question over here. What platform does the software run on, PC or Chromebook? This would be PC. This is not designed for Chromebook use, unfortunately. So that seemed to be the question. If there were any other questions, of course, you could type them in as well. So on that note, if you would like to take the next step, so whether that be requesting a quote, or if you would like to speak to your dedicated educational representative for your state to find out more about these 2 sets or any of the other educational solutions that we offer, as well as many other Fischertechnik-based solutions that we offer, you can simply call us here toll-free. The number in the US is 888-561-7521. If you prefer, you could email us. Of course, the email address is info@studica.com, and just reference the Studica Mechatronics program sets. If you would like to question me directly on anything, my email is up there as well. Lance.Zurek, LANCE.ZUREK @Studica.com. So if you do have any questions whatsoever about these 2 Studica Mechatronics program sets, or anything related to Fischertechnik and the Fischertechnik building system, you can email me there as well, and I'll be happy to help you out. So on that note, I'd like to thank you very much for taking the time to attend tonight's presentation. I hope you have a great day, and we look forward to hearing from you soon. Take care.